This is Module 1, Unit 3, Idea to Concept. This will be the final part of Unit 3. This week's overview for Unit 3, Idea to Concept, we will focus on 3.6, Presentations of Technical Drawings, and lastly 3.7, Getting Started with Design. Again, as a reminder, we are about to complete Unit 3, so this will be the end of Unit 3. The learning objective for this week will be to identify technical drawings, explore different design process. So let's get straight to it. We have something called sectioning. Now, sectioning is just an imaginary cutting section plane passing through a hidden detail of an object. If an engineer has a complex object with hidden details, external views may not be enough to show all these features. This makes it difficult to communicate with other designers. What happens is, on the bottom right of this slide, you can see an example of an object. This object, as you can see, has been sliced horizontally, and the result of it is right here. Once it has been sliced into its horizontal cut, you'll be able to see a detailed description of the object. If you then go ahead and draw your object, it will look like this on the bottom right. So sometimes what you need to focus on is only a small portion of the object to show its hidden detail. We are now moving on to something called dimensioning. Dimensioning is just the process of where you measure either the area or the volume of an object. If an engineer wants to design a part or a product and send it to the factory for production, all relevant dimensions must appear on the drawing, so you have to make sure that you write all the measurements in detail in your prototype to be produced. There should be no repetition in dimension. You should not repeat any dimensions in your object. Most of the important dimensions or measurements appear in the front view. As a front view, you'll be able to see all types of dimensions needed. To keep the drawing clean, all the dimensions are to put outside the drawing unless it is avoidable and makes the drawing difficult to read. Here at the bottom left, you can see the meaning of dimensioning. It could be a measure of the area, or it could be a measure of the volume. Next, extension lines indicate the part of the drawing that the dimension is being applied to. As you can see on the picture on the right, you'll be able to identify number 1 and number 2. Number 1, a small gap has to be kept between the extension line and the visible line. So there has to be some kind of small gap. As you can see here, there's a gap here and there's a gap right here. Moving on to number 2, an extension line should be extended about 3 millimeters from the utmost dimension line. So here as an example shows that exact example. Moving on to talk more about dimensioning. There are no strict rules on dimensioning. Okay, when it comes to dimensions, measurements, there are no strict rules. Use common sense and keep two things in mind. Dimensions any feature only once, so you're supposed to dimension or measure any feature only one time. Dimension so that there is no need to calculate any required size information. As an example, the recommended dimensioning is this one on the left, and the not recommended dimension is this one here. What do you notice the difference between the two? Obviously, you can see that this one on the right, which is not recommended, has measurements or dimensioning separately. So you have 30, 30 and 30. Whereas the recommended guideline is to have it once, twice, and then you can continue from the first to the third, which will give you 90. You can do a continuous one, but this time you don't need to specify the 90. You can go straight from the beginning to the fourth part, should I say, which will be 120. Moving on. If the space between the extension lines are too small, as you can see here, the space between here are too small, the dimension digits can be placed on either the left side or the right side. This number 10 here was not able to be placed inside the gap here, so therefore it's been pushed outside, either on the left, or you can even write it on the right. Works out the same. Here there is quite of a big gap, so you can put the dimension digits, and same thing for the last one. Now notice the difference between each. What do you see that is different? Obviously you can see that each digit has been doubled. 10, the double of 10 is 20, as you can see here. The double of 20 is 40, as you can see on the last square. Moving on to talk about circles, we can do dimensioning using circles as well. As an example, on the first picture, you can see that the dimension has been given 40 from this point to this point. Now, whether you started from the bottom to the top, or whether it's from here to here, it will still be the same. So every part of the circle will have the same dimensions. Here is another one, but this time this one has been halved. 40 divided by 2 gives you 20. So the first one uses extension and dimension lines, and the second one uses diametral dimension line, and the last one uses leader and note. Place the dimensions in the view exactly where the feature appears. The correct way to view this is this part here, whereas this part here is the wrong way to view the object specified above. This is the correct way to do the dimensions. This will be the side of the square, and this would be the top of the square. As you can see, there are measurements in dimensions, 25, 25, and this circle here is 20, whereas this doesn't have the dimensions given from there and from here, so that's wrong. Moving on to the last part of the technical drawings, we have something called tolerance. Now, tolerance describes dimensional accuracy, and it's important for the mass production, for the amount of production that you make. Mass production just means loads of productions that will be taking place when it's due for production. Absolute size is also known as nominal size and is only theoretical. So again, absolute size is same as nominal size. Tolerance specifies the acceptable upper and lower limits for a given nominal size. Moving on to the design process part. Now, getting started with design. The first point is define, which is basically looking at the problem. What is the problem? There are 3 questions that you can ask yourself: who, what, and why. So in define, you will have 3 questions: who, what, and why. And specifically, the first one will be what is the problem or the need, who has the problem or the need, why is it important to solve this problem. This moves on to the second point, which is research. You start doing research to find possible solutions to your problem. They will look at some designs that are already in place. You could look at anything that's already available that you can explore. The designer makes a list of design features of their idea. Moving on to the third step, which will be ideas. Ideas is when you start brainstorming and giving yourself ideas in mind. With this design feature listed, the designer then makes many sketches of the idea, which then leads us to the prototype. You start to create a prototype of the final solution. The prototype can be quite different to the final product because changes will be made. The prototype can be made using craft materials, card, paper, glue, and it can be 3D printed. Which leads us to the test and redesign. Now, the test and redesign is when you start testing out the prototype and then look at ways of redesigning it. If it fails, or if it works successfully, you can move on to the next stage. The last stage will be making and presenting. Now, making is when you start making the product and you finalize the product. Then you start presenting it to your audience or to the person who you're making the solution for. Many ways to make this happen is through posters showing the design process, a display of the prototype and the final product, a presentation, a group presentation of a shared design. So going back to tell you, number 1 is define, number 2 is research, number 3 is ideas, number 4 is prototype, number 5 is test and redesign, and number 6 is making and presenting. That's it for this week's presentation. Make sure again that you complete all the worksheets required, and making sure that all the PC worksheets are uploaded to your OneDrive. Now please make sure to subscribe, like and share. Thank you very much for watching. Goodbye.